Assalamu alaikum, Bismillahirrahmanirrahim, Assalamu alaikum, class. How are you all? I'm fine, Alhamdulillah, and hope that you all will be fine. In the last lecture, we have discussed the antenna parameters, and today we will start with the antenna elements. An antenna element is defined as the antenna type, and we have actually five antenna elements or types. An antenna should be fell in one of these categories, as the antennas are described only in these antenna element types. Okay, moving further, first one is the Herzian dipole or alternate current element. These antenna elements basically categorize in terms of the length, current distribution, and their current fed mechanism at which the signal is fed to the antenna. Number one is the Hertzian dipole alternate current element. As told before that they are categorized under three properties: length, current distribution, and their fed mechanism. Hertzian dipole come under the category of linear antenna. That is, all of the elements that are connected to make an antenna have the same characteristics, and the current distribution is kept or assumed to be constant in all of all of the length in all of the Hertzian dipole length. Remember that Hertzian dipole is considered or basically known as the reference antenna, and it is the ideal antenna, which in the practical implementation is not possible, as we don't have any antenna till today that has the constant current distribution in all of the elements. The second one is the short dipole. Short dipole is also in the category of linear antenna. The length of this antenna is considered to be as lambda by 4, and its current distribution is triangular. That means the current which flows in the in this dipole is in triangular pattern. The next is the short monopole. Short monopole again come under the category of linear antenna with the length of lambda by 8, and also the current distribution is triangular. It is the half of the size of the short dipole. It's known as monopole because it has one pole. The other pole is considered to be inside the ground or inside the earth. The fourth one is the next is the half wave dipole. As from the name, it is considered that the length of this is the half wave, that is lambda by 2, and the current distribution is sinusoidal. This half wave dipole is assumed to be have a sinusoidal current distribution across its dipole, and the length is half of the wavelength. It's fed from the center. That means we have a antenna that is fed from the center. The categories above half wave dipole, that is short monopole, short dipole, and Hertzian, can be fed from any side or in at the center, but particularly half wave dipole is fed from the center. The next one is the quarter wave monopole. Quarter wave monopole again is the one pole above the earth and other is inside the earth. It is also come under the category of linear with a length of lambda by 4, that is half of the half wave dipole. It also has the distribution of current distribution of sinusoid, and it's fed from the one end. Either from it's fed from the one end means it's fed from the end which is above the ground. So these are the antenna elements in order to categorize the antenna. The next is the radiation mechanism. I didn't write anything in the radiation mechanism as I have a plan to discuss with you. Uh, as I thought that you would not understand it by writing, or there is nothing descriptive to write in this under this heading. So we will discuss. I've tried to explain it in my words that radiation mechanism is basically, if you remember that I've told you in the start that electromagnetic wave is the combination of electrical and magnetic field, and these electric and magnetic field are created from the uh, time varying current or the continuous change in current, and that current is induced from the voltage, and that voltage is induced from any source. So first we have a source that is generating a voltage. That voltage is when through any resistance is produce a current. In a circuit it produces a current, and that instantaneous or time varying current produce electric field, and that instantaneous moving electric field basically created the magnetic field, and these electric and magnetic field form up and combine in a perpendicular manner in order for the electromagnetic wave to generate and to propagate throughout the free space. These particles distribute in all all directions, except if we decide to propagate a signal in a particular direction, we have to set that in a polarization manner. So actually the radiation mechanism is basically electric and magnetic field production or creation in a perpendicular manner in order to in order to make an electromagnetic wave propagating. So for this radiation mechanism we need a source and a transducer which will convert our source or our current through a transducer to electromagnetic wave, and that transducer is known as antenna. So the whole story of this radiation is basically from uh, a voltage and current. So the next is how we uh, gonna practically implement that radiation mechanism through voltage and current. In the last chapter, we have discussed the induction of voltage, uh, in which we have discussed two approaches, heuristic approach and Maxwell equation approach, in which we have, as I remembered, we have derived equations for V and A, and for Maxwell approach, we have an equation for V and A in form of del, which has been further simplified using the solution that has been created through a theorem. So those V and A are used here in order to derive the equations for these elements. First, we will discuss the Herzian dipole or alternate current element radiation equations, as because they are the reference antenna or the ideal antennas and ideal antenna elements. So here radiation field of alternate current element is not being derived. It has just the end result which has been come out of the derivation as the H, E, ER, HR, H theta and E phi. Basically we have three radiation patterns for each field. For magnetic field we have H theta, H phi and HR, and for electric field we have E theta, E phi and ER. So for radiation field for alternating current element, there only three value exist. The value exist are for H phi, E theta and ER. Other values like HR, H theta and H phi are considered to be zero as they all are derived and being the end result is retrieved as zero. So H phi, which have been come out as an end result, is equals to ideal sine theta divided by 4 pi multiplied by minus omega sine omega t divided by r v naught plus cos omega t d divided by r square. This is the value for H phi, and that is the value for the E theta, and then the value of the ER. The other values are considered to be zero as they are retrieved as zero in the derivation. And I have been told you before that all of the fields are derived from the previous approaches that has been used to drive the electric field or the electric potential and current. All the fields are derived from these two equations that have been generated in the previous chapter. Now, moving forward, alternating current element, radiated power and radiation resistance. The power that has been came out as the end result of the derivation is PR average, that is the average power, equals to n naught by 2 multiplied by omega I dl sin theta over 4 pi r v naught whole square, and the unit is watt per meter square. The transmitted power for alternating current element is derived out as 80 pi square dl by lambda whole square I square effective, that is in watts, and the radiation resistance is equals to 80 pi square dl by lambda whole square omega. The unit is ohms. Note that Herzian dipole alternate current element does not exist in real life, as I have been told you that these are the reference or ideal antenna because they assume to have constant current, which is not possible in practically. That's why we told you before that it is the or they are the ideal antennas. Next is the equations of power for half-wave dipole and quarter-wave monopole. The half-wave dipole is defined as this in the diagram. The total power is equals to is derived as And the end result is 73.08 I square effective measured in volts, and the radiated or the radiation resistance is equals to 73.08, which is measured in ohms. The quarter wave monopole is defined in the diagram that I've told you, or it is being considered as in the ground or above the ground. The power that has been derived out is equals for quarter wave monopole is equal to 36.54 current effective square measured in volts, and the radiation resistance equals to 36.54 current effective square measured in ohms. So these are the equation for power, resistance, and different fields for alternate current element and half wave and quarter wave monopole elements. The next is the radiation characteristics of dipoles. The radiation characteristics of different length of dipoles. That means we have some certain standard lengths of dipole that has been previously on originally characterized, universally characterized. We have some fixed length dipoles that have been characterized universally, and they are, if we have a length of dipole multiplied by 2, if we have a twice length of a dipole, the horizontal pattern for this twice length dipole will be this one, that is circular. The vertical pattern of short dipole is this, that is short dipole. This one, that has a length of lambda by 4. That short dipole is vertically polarized, and the pattern for this will be these two circles coinciding at a point. Then, if we have a dipole with length lambda by 2, and it is been if it is being vertically polarized, then the pattern of this dipole, first we will see what the type of dipole has a length of lambda by 2. That is half wave dipole has a length of lambda by 2. It means that we are talking about the half wave dipole that is vertically polarized. Half wave dipole that is vertically polarized has this pattern, which is much near to an ellipse, and that represents the vertical polarized half wave dipole. The next is the vertical polarized dipole of length lambda. That means if we have a dipole that has a length of lambda and that has been vertically polarized like this, then the shape of this or the pattern of this dipole should be like this, which is neither a circle nor an ellipse. It is something far different. But remember, the length is lambda. The next is the vertical pattern of dipole of length 3 lambda by 2. That means if we have a vertically polarized dipole of length 3 lambda by 2, if we have a vertically polarized dipole of length 3 lambda by 2, then the radiation pattern of that vertically polarized dipole will be like this. It is basically the combination of vertically polarized dipole of length lambda. It is basically the combination of that dipole of length lambda. As we can see that this pattern is here in the cross and also at the center. Then the last but not the least, the vertical pattern of dipole of length 2 lambda. Considered a vertically polarized dipole that has a length of 2 lambda. The shape of that antenna should be like this. It is also the combination of that vertically polarized dipole of length lambda, but the center pattern that has been observed in the 3 lambda by 2 dipole is missing. It only has two patterns crossing each other. So these are the universal field strength patterns of the standard dipole lengths, which defines different shapes. The one thing which should be remembered is this, that a question arises from these power strength or field strength patterns that we are talking about the vertical polarization, but as we can see that the patterns are horizontal. It's a very big question and you should have to ask this. The answer for this is that always remember that the vertically polarized antenna always comes out with the horizontal field pattern, and the horizontal polarized antenna or dipole element has always a vertical field pattern. So the summary is this, that the vertical polarized antenna creates a horizontal pattern and an horizontal polarized antenna creates a horizontal pattern. So Vertical, they are vice versa. Vertical polarized comes out with horizontal, and horizontal polarized comes out with vertical field pattern. So that's all for today. Thank you very much, and we'll meet inshallah in this week. Also, we have a Zoom class. I will announce inshallah in the WhatsApp group. Then when it has been arranged. Thank you very much. God bless us all. Allah Hafiz.